Welcome to our presentation by Dane, Ian, and Jason on the Singleton Pattern. To start off, we'll look at an explanation of what the Singleton Pattern is and how it's used and implemented a little bit in the programming world. The Singleton Pattern is essentially a design pattern created for programming efficiently. It is used mainly in object-oriented programming where there's classes and instances of these classes, and it is designed to ensure there is a single instance of any one class and a global way to access it. This is done to provide security to the application so that it doesn't crash, and so there's not multiple instances of something that should only exist once. A great example is a chess game. If you're playing chess, you have lots of different pieces, but the app that you're playing on shouldn't have two different chessboards created at the same time. So a designer may choose to use the Singleton pattern for the game board class so that only a single game board can be created at any one time in the game. This pattern is very widely used in the field today and is typically used on single thread programs where the program is designed to do a single thing at a time. Again, the chessboard might be a good example because there's the board created, it creates the board, and then the pieces, and then each piece is moved individually, only performing one task at a time. Below are a few different examples of Singleton pattern implemented in different languages here. We have Java, AspectJ, and Para-Ajax. They all have lots of similarities where there's a unique instance of the class. There's a private constructor that allows for it to stay within that class there and only be created, essentially, an instance one time. And then there's a public getInstance function or something along those lines that checks to see if there's already an instance and then returns a new one if there's not. This allows for only one to be initiated at any one time, and we can continue to go over that in the next slides.
Hi everybody, I'm Dane Layton. I'll be doing a short demonstration on the Singleton pattern. I've written out a short and easy class named Config Manager. There is a static instance of the Config Manager class as the main and most important member variable, and then we also have a static method that returns instance, which is a config manager, and that is also static so that it can access the static member. We can also have other private members, other private methods that the instance can access, but everything that this class is going to be doing is going to go through the instance member variable. So the two key things that we can see on this slide are, as I said, the static instance variable and the static method that returns the instance. It's very important for it to be static so that the one instance does not change when it's accessed multiple times.
The Singleton design pattern can be very useful for objects that are designed to only be created once, but are used several times throughout the program. For instance, it would make sense to only create and open a system log once, but still be able to write to it throughout the duration of the whole program. The Singleton design pattern also allows you to use lazy initialization, meaning that the resources are only allocated once you actually start using the object. For instance, the system log will only create and open the file when you first write to the file. If you never use the system log, then the file will never be opened. Because the resources are created only once and only when you need them, objects that follow the Singleton pattern typically use less resources than objects that are created multiple times. Objects that follow the Singleton pattern are effectively global, though they don't clog up the global namespace. For some programming languages, like Java, you have to use a Singleton pattern to even have global objects at all. Objects that were not meant to follow the singleton pattern will cause a lot of restrictions and complications. Making an animal singleton, for instance, will mean you can only ever have one animal, even though it makes sense to be able to create more than one. Singletons are often created to deviate from what's called the single responsibility principle, where each object is created to have one specific purpose. Most singletons are in charge of at least two things: creating an instance of itself, as well as following its usual responsibilities. Even though the resources are not allocated until you need them, the resources for a singleton will never be freed for the rest of the program's execution, even if you don't need them anymore. Because singletons can only be created once, it means you cannot inherit from them, because inherited objects will have to create two instances of the object, itself and the singleton it inherited from. Singleton objects are always global and can be used to hide its dependencies within encapsulation. For instance, the system log object doesn't immediately show that it's doing file I/O or on which file it's writing to. Its sole purpose is also to access a log globally instead of opening the file locally each time the programmer wants to write something to the log.
Dane again here for the recommendation portion of this presentation. The singleton pattern is best when an application needs one access point to methods and or data. Some examples would be, as in my previous example, if you have a configuration side of an application, you want one class to handle all of that, since all the data and methods are closely related. Another instance where you would want to use the singleton pattern is when you need unique data, like an account or a user ID. If you have two instances of the same class, there would be a chance for collisions to happen with an account number or a user ID or anything that needs to be unique. So that's another time when a singleton class would be useful, so that there's no chance of collisions and you're better able to keep track of previous user IDs or account numbers.
We hope you enjoyed our presentation on the singleton pattern and learned something new. We find it a very effective pattern of design for object-oriented programming that can be really implemented in many different ways and can be used to the great benefit of the designer and programmer. Included are our sources, so please take a look at these articles and read through them. They're very interesting and provided us with a lot of insight and understanding on the singleton pattern itself and how to best implement that and work with other patterns as well. Another recommendation is a book called Head First Design. It's a book that we use in CS 246 for software design and development. It works very well in explaining not only the singleton pattern but many other patterns, and is really a great help for us as well.